Okay, now I'm recording. So once again, when we're in class, turn your cameras on. We want to see each other. And then I record both the lectures and the reviews. On the class site, you'll see videos linked. Those are from last year. I'll be replacing those videos with the new ones. And then I don't link the old reviews because they're not relevant, but I'll be linking the reviews as we do that. So normally this part starts at quarter of. We're starting at quarter after, so this will be compressed, given everything we had to do in the first half. But today's lecture is on project management. And then again, there's a weekly cycle. I'm going to introduce the topic, project management today. At the end is the assignment. Once we get going, typically there's group as well as individual assignments. There's no group assignment yet. So your assignment is to sign the agreements, commit it to the repo, which I'll explain, work through a Git tutorial, which I'll explain, and then using the background today, you're going to build a personal website describing yourself in a final project. There's a lot you need to know to do that. I'll introduce it in the lecture, and you can nod and that all makes sense. And then you'll go away and be completely confused, typically. Then your lab will have hands-on sessions to help you. And then every Saturday, there's the team of Adrian, Pablo, Rico et al. Who host the Open Time, which is a global help time. Depending on where you are, there's also regional help times through the week. And then we present the work the next week. And starting next week, I'll run a random generator where I'll pick people at random to meet them, review what they did that week, and discuss final projects. And after about an hour of that, we'll then progress to just an open time to open any questions. And in that cycle, right after class, it doesn't make sense. As you go through the week, it'll start to make sense. When we review, it'll make more sense. Then each topic we're covering, we'll keep revisiting over and over. It'll make still more sense. Then you'll integrate it in the final project. And so each week, there's three things happening. I'm introducing what the topic is. I'm giving you the basic skills to do it. And then I'm pointing for where you learn to go more deeply. So don't worry about trying to master everything in one go immediately in the intro lectures. Then each week I link featured assignments. And this week I've linked 3 that are notable for their guides. These are people who did really good documentation. And you might get tired of hearing me talk about documentation, but it's a really important skill you'll be developing. These are 3 people who did really good documentation, and they each wrote really good sites about how to do Fab Academy, what you learned, lessons from it. This is one, she was maybe the most notable documenter ever. Here's a second one, tips and tricks on surviving the Fab Academy. And I'm going to talk about that towards the end of today's class. And then here's a third one on learning from mistakes, lessons from surviving. So I recommend reading through all of those. And once again, this is interactive. Post questions and comments to the chat. If something's burning, just unmute and join in. This isn't me broadcasting, this is interactive. So you need to build websites and you need to document your work. And we saw examples of the final projects. So how do you do that? So you have, here, let's see. let's go to prior years 2024 students. So Naldi presented. So here's Naldi's site. Here's who she is. And then there are her weekly assignments. And so here's what she did to document her work for this week. And then there's a final project. And then here's the site documenting how she did the final project. So that's what you're all, this is a nice example of all of these things. You're all going to build those. How do you do it? So the files live on a server, the Fab Academy server. You have a local computer you're working on. You need to get files between your computer and the server. These first, also, let me step back. We don't specify software. We're going to cover a range of software tools. Each week, I'm going to give you both commercial and open source options. You can do, let's see, examples of bad documentation. I'm going to link examples of bad projects. I link here to the worst final project ever. I haven't linked bad documentation. I'm not. Yeah, I'm trying to think how to do that without being too identifying. But the documentation should be enough to reproduce your work. So each week I'm going to cover. Yep.
Maybe we could talk about the characteristics of bad documentation.
Yeah. Yeah, it's a good point. So why do we document even? The documentation is for three reasons. One reason is just it's how we evaluate your work. We use your documentation, or maybe four reasons. We use your documentation to evaluate your work. Your documentation, here, let me add that to my to-dos. One reason is we use it to evaluate your work. The second is we use it, it's a portfolio. So when you go on and apply to admission, apply for funding, apply for employment, the portfolio you made documents your skills and you'll share it with other people. One is the act of documenting it helps you learn, and you'll find you regularly will refer back to your documentation as a resource yourself. And then finally, the documentation acts as a resource for future generations. So on the class site, there's a search engine. And if you want to make a drone, these are all drone projects made in Fab Labs. And so you can come into this and learn about how a previous student made a drone or how they did the weekly assignments. And so your documentation is helping teach future generations. And so the documentation has to be good enough for us to evaluate your work, but think about the documentation as your legacy. You're teaching posterity. And so it has to do a good job of teaching somebody following in your footsteps. So it's a good question. I'll add a note about why we document. And then, yeah, all the documentation goes into the repository, which I'm going to explain now. Other than a few very large files, all your documentation goes into the content management system I'm now about to talk about. And we do that to archive it. Links out of the repositories break very quickly. This is archival. So this is going to be a compressed intro given the shortened class today. These three tools help you synchronize files. This is a graphical version. rsync is a really, oh, sorry, let me go back one step. I was saying, I'm going to tell you about open source freely available tools and commercial tools. We'll make available, depending on which area it is, commercial tools that are used industrially, and I'll cover freely available tools. And so depending on your taste, you can do this all with open source. You can do it with any operating system, and you can do it with commercial tools. I tend to use Linux and open source tools by preference, but I'll cover a range of options. rsync is very efficiently at synchronizing. So I use that to do backups. If you have a server with a terabyte and you have a cloud server you want to replicate it, rsync very quickly copies files between them. So it's very handy for backup. It goes in one direction. Unison isn't quite as efficient, but goes in both directions. So I use that for low-level file copying. These all do version control, and there's an interesting history for them. We're going to be using Git. Git was written by one of the main developers of Linux, Linus Torvalds. And in British English, Git is an annoying person, and he's an annoying person, and that's why it's called Git. That's roughly the historical lesson. This is a link to the Git project. It's very well documented. This is a link to a graphical interface. GitHub is where many open source projects live. GitLab is there's commercial versions, but it's an open source version of a private cloud version. So in the Fab Academy, we're using GitLab. And this does about 10 different things. I'm going to come back to this page after I cover everything else. On your computer, the file browser just shows your files. There's many things we need beyond that. So one of the things we need is history. So when you're working on a project, you might have multiple versions. You have a production version, you have a debugging version, you might test different components, you might have versions for different languages. And so one of the things you need to do is manage branches to have multiple versions of a project, and you need to manage history. So you can have the working version of the project, and then you can have simultaneously a development version that you're testing but isn't working. And so you're publishing the working version while you're doing the development. So one of the things Git does is manages history. So your file system isn't just the present, it's snapshots of the past. A second thing you have to do is branching and merging when you collaborate. So in machine building, you might have 10 different people working on the machine, and you have people working on different parts of the design. And so you need to be able to work separately on your own areas, and you need to be able to merge your work back together again. So branching and merging is a second thing it does. A third thing it does is it lets you push and pull. So the repository is this folder that has files and history, and you each have one on our server. You're going to pull from that to work on your local computer, and then you're going to push your work back from it. I'll come back and go through. You can use an interface from a web browser. So if I go to, right now I'm in GitLab, and I can come in here and I can, because I have permissions, I can take, this is the main website, and I can edit it here. But it's fairly cumbersome to edit through the simple web interface. You can do that. The more powerful thing you can do is you can pull the repository onto your local computer. Then you work on the local computer until you're happy, and then you push your work back to the server. And when you do that, you're not copying everything. You're just pulling whatever is changed. You do your work, and then you push back to the server whatever else is new. And so a third thing it does is it manages that process of pushing and pulling. And so think about the Git repository as a website, as a file system, and as history. And that's how you're going to manage your content in the class. That's what you need to document your work. But along the way, one of the things you'll be learning is how to do version control and how to build websites. It's frustrating when you start. Learning version control, it's not gentle. It's kind of a steep learning curve. But once you're done, learning it is one of the most useful things we'll teach. There's a note, the Bazaar link is dead. Bazaar was a version control system that's historical. It's not really in use anymore. I, in this class, have used all of these. It's really there for history. I'll check that. Now, I'm going to come back. This last link talks about the class archive. I'm going to finish going through this page, and then I'll come back and drill in more detail on Git. Cloud services like Dropbox under the hood are using a tool like Git, but here you use it explicitly. And so my whole life is in Git. On my phone, and I'll show you this in a minute, I run tools that let me put Git repos on my phone. And so every day I pull a repo with all of the things I'm doing, I do my work, and then I just push it back. So essentially, everything I do in life lives in Git repos. So I'm going to come back and talk in more detail after I cover the other parts. You're going to build a website. So there's a web server that's serving the website. Each of you has a starter website. Here's your starter site that you're going to be editing, building, and modifying. You can view it on the server, but when you're developing, it helps to view it locally. So to view websites locally, Nginx and Apache are standard web servers. You can run those on a server. You can run it locally. Web browsers let you open locally. So you can just open a web page locally by opening it with a file prefix. And then Node and Python, we're going to be seeing a lot in this class. Those are both languages that have an important role. Both Node and Python let you easily run a web server. So with either of these commands, you can run a web server locally. You can view, rather than having to keep pushing your website to the server, you can view your website locally while you're developing it and just push it at the very end. So it's helpful to be able to run the local web server. So then you're going to build web pages. This is where the web is documented, the organization. Mozilla, that makes the Firefox browser, has a really good reference site that documents the web codes. And then I'll be talking about extensions to the web called HTML5 as we progress. There are all sorts of sites that give you templates. This is a nice site of templates for building websites. So to do web development, one of the things you can do that I recommend is just view source. So Control-U is a shortcut. Here's the code for this web page. And so that's the raw code. The lowest level is just to write at this level. And that's, in fact, what I do. In general, there are many ways. I'm not going to be a good guide because I like to use the very lowest level possible. And so I tend to write just raw HTML code. But so that's what it looks like. Then above that is the editor. So I use an ancient editor that's almost a religion called VI. This dates before there were Windows and mice. And the reason that's meaningful is in VI, you can do absolutely everything without your hands leaving the keyboard. You don't have to keep reaching to and from a mouse. Just by keeping your hands in the keyboard, you can do every possible kind of editing. And so that's my preferred editor. That's a very low level. Then Atom, VS Code, Sublime are all much more powerful editors. So VS Code, we're going to see in many different contexts. It has plugins that understand web editing and give you all sorts of support. So there's plugins for writing C code, for writing HTML code. The editor adapts to what you're doing. So I recommend an editor like that. Then as we move up to the more advanced editors, LibreOffice is a free open source office suite. And let me make a note. It's WYSIWYG. What you see is what you get. And it's a free version. Dreamweaver is a commercial version. What those let you do is build websites without having to know the codes. It's just a graphical interface. What's good about that is it's a nice high-level graphical interface. What's bad about that is they make generally ugly HTML. If you use them, you can't really edit by hand. You have to stay in the GUI environment. So it's good if the GUI does what you want. JavaScript is how we build interactivity into web pages. And I'll be talking about JavaScript quite a bit as we get to higher level program. These are then all abstractions above HTML. To write a web page at the level of HTML, you have to know low-level codes. Markdown lets you write human-readable text and just have various punctuation characters that get turned into web pages. And so you can build your web pages with that. And then these are tools that let you build websites using Markdown. And so you can do the class with that. I recommend starting at the level of HTML, but then you can move to Markdown. Then CI/CD is automation. So one of the main things that GitLab does is it houses the repos, but it lets you build workflows. And so, for example, when you signed up for the Fab Academy, your site was constructed, and and then when you do your work, it gets published. And I realized I didn't do two important intros. Julian, are you on the call still? I neglected to introduce Julian, but he handles the IT that makes that all possible. And Luciana, are you on the call? Yeah, I'll make a note to introduce both of them
Neil,
next
when you
week.
dropped out, Luciana very briefly introduced herself.
Oh, okay, good. Okay. So yeah, we'll introduce Julian next week. He handles the IT. And so CI/CD has to do with, along with the repository, you build workflows. Like a simple example is this page isn't actually directly written. In my lab, this page is automatically generated by one of these workflows from all the repositories of all the other tools. Oh yeah, and Narella, let me make a note. to introduce all of them next week. Chris, I've never heard of Zed. Is that interesting?
Oh, Zed is one of those new AI text editors.
Okay. So you're going to be, what I would recommend is explore this range of low to high level editors and pick one that's comfortable for you. And everybody has different tastes. And then you're going to be using that to build websites. This group is content management systems. And so you might encounter some of these, for example, in classes. We're not using a content management system because you'll find the websites are very expressive. We don't have a fixed format. Everybody builds a different website and it becomes very expressive. It tells you who you are. We want you to build personalized sites. We want you to learn how to build websites, and we want you to learn how to do version control rather than locking down with a fixed way to present. This group, we don't really need to cover yet. As we get to video, I'll be talking about protocols for video. Right now, our ability to see each other is running through a web RTC protocol that does video through the web, and we'll learn how to read and write to that directly so embedded devices can send video. We're using Zoom, and we use Zoom because it scales to huge meetings. Right now, there's a few hundred people in the meeting. Jitsi lets you make open source video meetings, but it doesn't, which is convenient, it doesn't scale that large. And OBS Studio is a good thing to know. You have a speaker, a microphone, and a camera. OBS Studio turns your computer into a whole production studio where you can take multiple sources of content and turn them into video feeds and mix audio feeds. And so it lets you manage, think about managing like a high production value TV show. So it turns your computer into a production studio, and it's a nice open source tool. These are tools for remotely sharing desktops. We're going to see that when we get to application development. These are tools for doing project management. Initially, you won't need them. All of them let you do something that looks like this. It lets you keep track of tasks and schedules. You won't need that at the beginning. And GitLab also has a number of these tools built in. Let's see, I'm seeing a note about Cursor also as an editor. The reason these tools matter is not the foreground, but the background of this class is project management. Other names for the class are how to almost make almost anything or how to fail at almost anything. You're going to be failing every week and recovering. And so learning how to manage projects is going to be essential. So one is the 80-20 principle is 80% of the work takes 20% of the time, and 20% of the work takes 80% of the time. So when you build a house, it goes up quickly, but finishing all the plumbing and wiring can take forever. In your final project, it'll come together pretty quickly, but not quite work. And the last little bit to get it work takes much of the time. So you need to be prepared for that. Demand side management is where you do a task and then you do another task and you do another task and you run out of time. Supply side time management is you take the available time and you divide it up and you figure out a schedule. And that's one of the key skills in this class. You have 1 week to get your website up. So give yourself a day to do a Git tutorial, a day to test the website, a day to document yourself, a day to think up a final project, a day to document it. Make a schedule for each week. And as we progress, make a schedule for between the weeks. you need to work to a schedule rather than just doing tasks and you'll run out of time. Triage is when an airplane crashes and the first responders come, you need to separate the people walking who might be wounded, but they're going to survive, the people who are so injured they're not going to survive and it's not worth trying, and the people you can save. And that's going to happen each week and in your final project. There are going to be things you want to do that you just need to give up on. Things that are fine you can do later, and find the things you need to pay attention to. Serial development is where you do task, 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 and if one task gets stuck, you don't get to a later essential task. So it's important to manage parallel tasks so no one task can block another one. Spiral development is one of the main concepts you'll hear from me over and over and over. Spiral development is like the US Department of Defense used to have examples where it would spend 10 years and $1 billion, and at the end of it, get something that doesn't work. Spiral development is you work in spirals. Each spiral brings you back to the beginning where you have a complete working something, and then you add features. So the first spiral is use the website that we gave you. The second spiral is just add some words to it. The third spiral would be change the presentation of the website. But each trip around, you have a working website. Don't spend the whole week before you test the website. When we do sensors, a first spiral is a pre-made sensor. A second spiral is you make your own sensor. The third spiral is a more advanced one. Over and over, I'll be raising this notion of spiral development. Make something you can test and then add features. Don't try to do everything in one go. As we work, hierarchy and modularity are going to be important. When you make your final project and it doesn't work, what do? You can either start removing components until it does work, or you can start from the bottom up and add separate simple components and build up to it. And one of the recitations will talk a lot about that. You will not have time to document if you wait until just before class. The only way you can survive is if you document as you go. So documentation has to be part of your daily work cycle. Every day work and document what you did that work. You can look up the acronym. This means don't use your instructors to skip you reading manuals for what we're covering. And I'll be covering lots of examples of that. This is a really good book with stories about project management. I recommend. It's full of really great insights into project management. Every one of these has been the subject of billion-dollar failures. These may sound like they make sense, but they're really skills to learn. And you're going to run into every one of these principles as problems, and as you progress, skills to master. So I'm introducing this at the beginning. I'm going to recap it at the end towards final projects. It's really important to take project management as a skill you explicitly study, not just something you hope works out. It's one of the core things you'll be developing in this class. So that's project management. Let's see, there's a note that the HowToWiki link is wrong. Yeah, Patrick, HTML is what the web uses. HTML is lower level, but not simpler. So let me give you an example of both. And then, so in the documents page, here's a website. This is what Markdown looks like. Markdown is human readable. It's very easy to write. And then you need something that converts that into a web page. And so those are those frameworks. This is a web page. The web page has these codes. So the web page, when you're starting, is a little bit more complex because you need to know the codes. But that's the lowest level. That's what web browsers understand. Markdown is easier to understand, but you need to convert it from Markdown into HTML. Okay, now, mindful of time, I'm going to jump back to this link to class archive. This is now specific for what we're doing. So this is a Git tutorial from Git. This is a really good page on problems in Git. These are all insights into Git. The reason I say that is to use Git, you need to understand the concepts of cloning, pulling, adding, committing, pushing, merging, branching, forking. You cannot learn Git by clicking and dragging. There's no way around. You just have to work through a Git tutorial. It won't make sense without it, but it's one of the most important skills you're going to learn. It's really worth doing. You can get Git from Git. There are graphical interfaces. So these are all GUIs for Git. You can run those. As you get better, you probably won't. So the more advanced you get, Bash is a standard terminal that you can run in any of the operating systems. As you get better, you can do Git just from a terminal, and it's much faster than doing it by clicking and dragging. So there's kind of a hierarchy from you can edit your site through GitLab in the cloud. Better is to pull it locally and edit, use the GUI. And even more efficient is just to use the commands in a terminal. And so in Windows, well, I'll talk about that now, Marco. So in Mac, Homebrew is the package manager. And with Homebrew, you can install Bash and Git. In Windows, I don't recommend PowerShell. So Microsoft recognized Linux was racing away from it for developer preference. So the Windows subsystem for Linux lets you install a complete Linux subsystem in Windows. Cygwin is another way to do it with a compatibility layer, and Git itself installs a terminal. If you're in Windows, I recommend actually doing the Windows subsystem for Linux, but any of these let you do Windows. And then I do all of this in Linux. I use Ubuntu. These are scripts to install and configure it. On my phone, this is what I was mentioning. Termux lets you install Git, Bash, and all these tools on your phone, which is what I live in. And then for iOS, this is for iOS. There's a question about, are you not seeing what I'm sharing? The screen I'm sharing comes from the Fab Academy site. Oh, sorry, that was just Director Ricardo. This is, I just put in the chat the page I'm on. To find it, let me go through the sequence. If you go to Fab Academy, Content 2025, Schedule, and then Project Management, and then you get to where we are. Oh, and then, sorry, this page is linked off of that page, and I see, yeah, okay, that just went in. Okay, so you need to get a version, and then this is what I was saying. This is going to be history, merging, collaboration. Initially, you'll do this on the server. When you start working locally, there's a number of things you'll run into that you'll need help with. You're going to use what's called a key. It's a cryptographic file, and that's how you prove who you are. And so your lab will help you get set up with it. Then you'll pull, you'll work, you'll push. One note is in file paths, you can't avoid using spaces and non-ASCII characters. Some browsers, some operating systems have trouble with that. All your content goes in the repository. We can only evaluate stuff in the repository. Then this is a really important one. This was part of the video at the beginning. We want megabytes per week, adding up to hundreds of megabytes for the semester, which adds up to gigabytes per lab, which adds up to hundreds of gigabytes per session. File storage has gotten cheaper and cheaper, but one reason we want to keep the file size down is this is archival storage that's maintained and backed up, and this is more expensive storage. But the other reason is for your website to be responsive. If you have giant assets, it takes a very long time to view them. So something we'll be going at over and over is how to manage the size of what you're creating to not consume a huge amount on the server and for your viewers to download efficiently. So DU and NCDU are tools I'll be using to check sites, and we'll be going through in next week's class how to compress images and videos. And early on, I'll be checking on file size, and I'll be flagging sites that get too large to go through how to do that. So your lab will go through how to config. And actually, let me make that. I'm going to update the assignment in a simple way. Each week, there's a group assignment, and I'm going to add a note to make a group assignment for your group to show how to do this part, which is how to configure a computer to push and pull locally, to teach that. So next here, I have a long list of things that right now your eyes will glaze over, but you can do these through the web interface. You can do this with the GUI. These are the commands. These are all the different operations I do in Git. So these are all the steps to set up a repository, pull and push, and edit it. And down here, I do this so much. I have a series of just shortcuts that these are a few letters I type just to make it real quick and easy to do it. So these are all of my shortcuts. One of the things you can do, I recommend, is you don't just need the class server. Once you install Git, you can make your own Git repository, and you can play with that. Make it, create a Git repo. Up here, I describe, you can create a repository, you can commit, you can branch, merge. Before you even touch the server, you can do that with your own Git repository. So these are a bunch of links for the class archive. So the goal this week is, if we go back to the class site, you all have a starting website. Here's the website. It's in your own personal Git repository. Start by editing this site, but you don't need to be stuck with this. You can use any of the tools I described, and you can personalize the site to make it look however you want to look. The goal for this week is get set to edit your site. Just do some basic tests to get it working. Read a Git tutorial. Get set up to push and pull your repositories. And then build a personal site describing you. And then describe a starting final project. Your final project will change significantly, most likely, but just start by describing what you think a final project might be. And at the end of the semester, let me jump to that link. Once we get up to, and a link. I need to link to that page. The final project needs to show additive and subtractive fabrication, electronics design and production, designing and programming with embedded processors, building system integration, and packaging. Okay, so that's going to be the assignment. Now, in the schedule, let's go back to that. We have a Saturday open time. That one is 10 o'clock Boston. Is that right, Adrian? Yep. So 10 o'clock Boston, there's a great team that hosts an open time, and this is for just any help with anything you want. Then your lab will have help sessions in your lab. Depending on your local network, there can be regional sessions. And then every other week, we have a recitation. The recitation supplements, and on Monday at 5, what I gave you was a quick intro to Git. The recitation on Monday, oh, good, and it looks, oh no, it's not linked yet. The recitation on Monday, Julian is going to give you a much slower introduction to Git and web development. So at the end of 1 week, you won't be a master web developer and you won't be a master of Git. What we want from 1 week is just you've started, you've edited a web page, and you've made a commit, and then those skills will develop as we progress. Okay, any questions? If not, take to heart the advice that make a schedule for the week and document each day as you work. And those are key skills to make this sane rather than running out of time each week. And get ready for an amazing collaboration. As we progress, as you've seen already in the chat, the knowledge in the class comes from the class. It's not all central from me out. And you're going to get to know so many of the people who have been popping up in this community. And so along with everything else we're doing, you're now joining a remarkable global network. So let's see, questions of, if you already have Git, that's great. Just work with your local instructor, work with the open time to get your Git setup interfaced with the server. Each of your sites, when you go to your site on GitLab, it has the information you need to push and pull from it if you're already familiar with Git. Okay, so oh yeah, for the weekly assignment, yeah, just if you know all of this, you don't need to document learning Git if you're already familiar with it. You just need to document. Let's come back to at the end of this week. We want to know who you are, what the possible fine art project is. If you're a beginner, do document learning Git. If you already know it, you don't need to repeat that. You can just mention your familiarity. Oh, and Pablo's also noting, in addition to all the other tools, there's issue trackers we use to track issues in GitLab, and we'll be seeing that. And then Mattermost is like an open source analog to Slack for chat, and the Mattermost channel is a very busy channel sharing comments, feedback, anything to do with the class. So lots of different ways to get help. Okay, welcome to the Fab Academy. The first class is done, and I look forward to beginning to meet you all. Let's see, come Saturday for open help. We'll see you at the Monday recitation with Julian, and then next Wednesday we'll start meeting all of you. And a nice tradition is at the end of class, unmute, and we all say goodbye in our local language. Goodbye.
Bye.
May một câu sir.
Bye.
Bye, hi guys.